Well, thank you very much to the Valley family to allow us to present here. We're going to talk about a lithium project. Most people worldwide are not very aware of lithium as a commodity and how to explore and how to find it. So I will go over this new discovery and I will make some special notes on the topics that you need to pay attention to compare with other potential projects. This is a project that is located in what is called the Lithium Triangle. Lithium comes from two different sources: hard rocks, which are pegmatites, which have more or less a global distribution and have several producers and several incoming projects, and brines. There is only 3 lithium producing mines in the world, 3 significant ones, and 2 more that are very small. So 50% of the lithium production comes from lithium brines, and actually 90% of the lithium brine resources are located in this region, which is border between Bolivia, Argentina, and Chile. Now, for each group of salars, like this, for example, which is in the Atacama area, and the Atacama salar is actually the #1 lithium brine producer worldwide. Now, this is #2, where there's 2 operating mines here. There is 1 operating mine there from FMC and 2 projects. And here there is 2 development projects. As a matter of fact, our group developed the Cauchari lithium project back 5 years ago. Now, we are located here, south of these 3 districts. But the particular positive point is that we own 100% of the salar. As a matter of fact, it's the first time that a company controls all the district. So we own one, there's no options or anything like that. It's direct ownership of the entire district. What you see here, that looks like a very nice lake, this is no water. This is brine. You're looking at a lake of brine. So it's the first time in my life that I can take a picture of the ore body, because the ore body is in plain sight. Not only that, this is actually the 3rd highest grade lithium brine in the world. Now, this lake is actually extending inside the guts of this salar. The salar is basically a porous rock that contains in the porous space the liquid, this liquid, that is the brine. So usually this is a similar play as oil and gas, where you are looking at porous rocks that contain the oil inside, from which you are going to extract. The difference is that oil and gas is usually hundreds, actually usually thousands of meters deep, and in this case, you're only near surface or down 300 meters deep. So one tip here, when you are comparing lithium brine projects, is footprint. If I tell you that I have a bottle of wine and I have 1 liter of wine inside the bottle, you're probably going to believe it. It's a liter, inside a bottle, or 750 millimeters. But if I tell you that I have 100 liters of wine inside my bottle of wine, you're probably not going to believe me. Footprint is very important because it's basically telling you the area where you can host this. So when you're comparing lithium companies, always think that they need to have a footprint large enough to actually hold that liquid. This is actually This is actually the project. And what you see here is the salar I just showed you the picture of. And what you see here is the lakes. As a matter of fact, there are 2 lakes. Both of them contain brine. Okay? And there is another few salars down south which have less technical importance. This is the area we're going to focus. And these stars that you see there are hot springs. So there is input of hydrothermal water inside the salar and the lakes. What you see here is actually, these points represent a sample. And remember, we are not sampling rocks, we are sampling liquids, okay? If you are in a lake, you are sampling liquids at different depths. And if you are in the salar, you are sampling liquids from surface, breaking the salt and actually allowing the brine to basically get out of the hole and sample, or drilling and then sampling the brine at depth. What you see here is what we call the northern target, and that area here, the northern target, has an average grade of 866 milligrams per liter lithium, which is actually the third highest grade lithium project in the world. It also contains potassium, which is a byproduct that adds a little bit, not much value to the project. And then you have a southern target that has lower grade. While this has an average of 866 milligrams per liter, the southern target goes around 200 milligrams per liter, so a lot less. Just to make the point, in the United States, there is a very small lithium brine mine that is in production and has half the grade of the low grade of this area. Okay. Now, this is impurities, and this is another warning sign, very important. When you are comparing lithium projects, impurities are key, because magnesium, for example, can literally kill your brine project, okay? So if you have high magnesium, you will not be able to put in production. It doesn't matter how much lithium you have. So when you're into this business, you're not only looking for rich lithium brine, but you're also looking that that brine contains low magnesium and low sulfates. Here you have the lithium and the sulfate content, and you can see that the northern target in particularly have very, very low sulfate and lithium. I will sulfate and magnesium. I will further develop on this in a second. This I want to show you here is a hot spring feeding the lake. Now, I know this is difficult to see, but those there are two trucks, and here are not ants, are actually people. So this is the hot spring. This hot spring contains 566 milligrams per liter lithium. So lithium is added every day into the lake, and the lake acts as an evaporation pond, further concentrating the lithium. So somehow, somebody could say that this is a renewable resource. Others could say that this is a mineral deposit in formation, as we actually see it. This is just a comparative table, and it's showing you mines in production up here and our project. So our project has higher grade than some current mines in production. This is a very important graphic you need to test when you are comparing with other companies. This is the magnesium content and the sulfate content. With more than 10 times more magnesium than lithium, all these projects, including this, none is in production. And they are very big. Uyuni is world famous in Bolivia, like one of the largest lithium deposits in the world. It doesn't matter how big they are. The magnesium literally killed the project. There's no technology to take the magnesium out at a profitable, in a profitable way. Now, when you see the sulfate, and I give you right there, this Abuja is in China. The operational cost is around $5,000. When you see Silver Peak in the United States, the operational cost is around $4,000. When you see Hombre Muerto, Atacama, the operational costs are around $3,000 or a little bit less for Atacama. Now, this is our project. It's the lowest impurity project in the world. We discovered this in 2015. I'm not going to go through technical, just to mention that in a period of 1 year, we have completed geophysics to understand how the salar is at depth. So we learned that we have 200 or 300 meters or up to 500 meters of salt and sediments inside the salar. Then we completed drilling. We completed drilling in the northern target and in the southern target. In the northern target, all the drilling down 200 meters shows similar grades than on surface. Therefore, you have footprint and you have depth. By now, 3 dimensions, you are getting close to have a resource. Then well, the interesting news, the amazing news, is that the southern target that we kind of disregard from the exploration perspective because it only had like 200 milligrams of lithium per liter on surface. When we drill, big surprise, 500, 460. So actually at depth, the southern target does run lithium. Not as much as the northern target, but still very good and in the future profitable resources down there. So now, again, think about oil and gas here. When you want to measure resource, you need porosity. In other words, we are looking at how much liquid you have inside those rocks. In the lake, porosity is 100% because it's just liquid. But in a rock, the porosity is actually need to be measured. We did that all across the northern target and the southern target. We found very good porosities, and we have different aquifers, which means literally you have different ore bodies, one on top of the other. So what I'm talking about? This. Look, this is the upper aquifer, so it goes down 70 meters of porous rocks that contains the brine. And then a lower aquifer, which is open at depth, which starts somewhere around 150 meters with more brine at depth. Both are high grade, so this is multiple stacks of geological history accumulating the brine in the porous rocks. Very important, and of course that will make the resource bigger. We have completed all metallurgical studies that prove that only evaporating the brine will actually get all the way to 7% lithium in the brine, and then we can actually produce lithium carbonate from that high concentrated brine. So all the metallurgical studies that are required to understand how to process the brine are completed. This is the way the brine is concentrated. These are pilot ponds that we have built. This is the salar that you see here, and there is a well that is actually feeding those ponds. So the ponds basically evaporate during 1 year to get the brine from the current, say, 800 milligrams per liter to 6%. We have done this in very, very short time. I personally discovered this mineral deposit with my son in December 2015. From December 2015 to July 2016, we completed a 43-101 report and took the company public in an IPO at $1. We raised $18 million. After that, more recently, like a month ago, we raised another $25 million with major bankers like JP Morgan, M&G, BlackRock, and so on. And with that money, we are fully financed all the way to final feasibility. So notice that we have progressed a lot. We are fully permitted from the environmental perspective. We have social license. We have gone through all the process of public audience, and we have very strong support at provincial, local government, and in the town. We expect to release our resource in a couple of, actually in April. However, anybody who cares can actually do their own numbers, just looking at the porosity, the grade, and the drill results. So it's an easy exercise. We are completing our preliminary economic assessment that will be done by the spring, and 1 year after, the full feasibility. Okay, a little bit, there is about 20% ownership. I personally, one of the largest shareholders of the company, I put my own money into this, as well as, I say, 3 or 4 very large funds worldwide. So about 60% of the company is held by large funds or myself. The team that we put together is exactly the same team that we use Lithium Americas. Lithium Americas discovered Cauchari and sold 50% of the project to SQM, proving that the things that we have discovered in the past are actually real ore bodies. This is the team, part of the team that is putting together. We hired GHT, which is an engineering firm from Australia that have actually contracted most of the SQM guys. Most of the guys that you see in our team are former SQM, which is the largest lithium brine producer in the world. People, okay? So thank you very much for your attention. I'm open for questions. I know that lithium is something new. However, everybody has a good understanding of the needs for lithium with the incoming of electric vehicles and computers and all type of new batteries. And we are open to discuss all these new technologies in our booth, shall you want. Thank you very much.